this, most of this is, the first part of this is repeat from last time, but I'm just going to go through it again right there. And I brought another pen. I don't know if it'll work or not. Let me see if it'll work or not. Right there. Now, oh, this pin actually does write in the right place. This one, now they both write on, it's the projector, that's what it is. I remember now that it's the projector. So this projector lets me use the pen. Right there. Okay. So, everyone recognizes this. Did I start the recording? Okay. Yep. Okay. I already started. The joke around our house is that my white spot caused me to do that. If you look at my MRI, there's 2 white spots from where I had the. Okay. Most of you probably recognize this picture. This is the original R2-D2 from the 1970s Star Wars movie. Such a big hit that they keep remaking them and remaking them. None of them are as good as the original 3, but they keep making them. And of course Princess Leia was a lot, was cute back then. Unfortunately she's passed away last year or so. But robots have been around a long time. There. So there's been many implementations of robots over the years. Back in the 1980s, a company called Radio Shack, sold a kit called it was called a Heath kit, but it was called the Hero H1 robot or whatever, and they sold it as a kit predominantly to hobbyists and schools. I put one of them together, there at the university, and then later I ran a course where we had a bunch of high school students and teachers come in and build a bunch of them. So I've been around these little, and that robot, I don't know if I could find it. Well, actually, in order to find it, I would have to turn on my internet. Right there, and it should come up and tell me, yeah, here we go. And I don't know why I go through this. My browser is kind enough to remember my password. That's why I have to keep a password on the computer. Robot. Right there. And hopefully it comes up. And of course our internet is blazing fast. A Hero robot, there we go. Oh, it looks like someone still sells parts for them. And come on. I don't want. And that's what it looked like right there. So, I mean, you can tell it's got the little programming keypad on the top. And if you were to expand that out, and the picture isn't very clear, but it's a hexadecimal keypad. It was built in '88. Well, I didn't realize it was that expensive. I didn't buy it at the university that I was working for at the time, bought it, but it was $1,500 at the time. That's there. And I'm not sure if that included the arm. Right there. They sold a Junior, which I've never seen the Junior. Right there. The 2000, I've never seen one of those. Those came out a few years later. And then they came out with the Key robot that had a camera in it. It cost $8,000, so you can tell why I never saw one. They were fairly expensive. But Radio Shack was a company in the U.S. I think they're finally bankrupt. They actually had a store in IOI Mall up to recently. It may still be there, a Radio Shack right there. But this is the old that there, and it had an arm over here where you can pick things up and move things. So for its day, it was very impressive right there. So, and again, it had the Hero 1 editor and compiler that, you know, so you can program with with an IBM Write Will programs for. So they've been around a long time right there. So going back to our slideshow here, right there. And as you look at that Hero robot and you look at R2-D2, you can see that some similarities up there. So, okay, one part of the robot is the manipulator. The manipulator is what that there, again, I went through that last time. That's essentially the arm that there, right there. So this is a Puma robot, and it's got one arm here, and it's got another arm here, and there's a pivot point here. There's a pivot point here, and then there's a rotation here, right there. This one here, the only pivot is up and down, right there, and then the action occurs in this direction. So not all robots move in the same way, right there. So we also have, if you watch the video, they had, you know, they were working on leg robots. This is one that uses the spider insect type right movement with 4 legs. There are 6-leg and even 8-leg robots that there. I think someone put together like a 40-leg robot that there. I haven't seen that particular one. It kind of resembles a centipede. Many of the robots in use today are wheeled robots. If you look at robots that are used for search and rescue, military applications, things like that, where they're trying to, they'll use some type of track. This happens to be spiked tires for a very rough surface. They have them with tracks that look like a tank, right there. I've taught in the past, and I continue on occasion to teach a course for an online university in the U.S. of technology on where the students are all required to build a robotic car, which I'll use some of those examples later in this class. I actually have all the parts for the car. I don't have an assembled car because unfortunately I keep taking it apart and using the parts for labs that there. But I've got videos of the car and that there. But I've had students in that class that will actually replace the wheels that they're given with a track. You know, they'll go ahead and add that there. But we have leg robots, wheeled robots, right there. We have some robots that are underwater. This is probably going to be a growing area of underwater robots. And one of the areas which they're being used a great deal, and there's a lot of research, is in developing wind farms off the coast. If you were to look at, say, Denmark in Europe, they get about 40% of their electricity from wind. And they got these giant wind turbine fields out in the North Sea where it's very windy. I know none of you have been to the North Sea. I unfortunately have been on the coastline of the North Sea up in Scotland. And there's two things about the North Sea. Is one, it's very far north, which means it's colder than the dickens year round. You don't swim in the North Sea. Yeah, it's too cold. But there's a lot of oil in the North Sea, up there. But it's also very windy out there. So, and of course the North Sea goes on over into Russia and then over to Iceland and Greenland and Scandinavia touches out there. So it's pretty far north. And Denmark's one of the countries in Scandinavia along with Sweden that take a large advantage of, they take advantage of the high wind that you typically find there. Malaysia doesn't get the consistent high wind in its coastal areas, so but it gets pretty windy. If you go to Tioman or Langkawi, you've got a pretty good breeze coming off the South China Sea or the Indian Ocean, but it's nothing like the North Sea. or the North Atlantic. You know, you go up to Newfoundland in Canada, that they're, so, but they build a lot of underwater, and a lot of this construction and inspection is down deep by the seabed right there. So autonomous water vehicles are going to be coming, that they're, and of course there's multiple problems with autonomous underwater vehicles. One is they have to be waterproof. You know, that's a problem that's I'm very familiar with, having worked in the submarine detection business back in industry, where our sonobuoys had to be waterproof. That we dropped them in the ocean, listened for submarines that there. And communications are, to the submarine is much more difficult that there when you're dealing with an underwater vehicle. You don't have the luxury of, you know, radio communications as easily. You know, those problems have been roughly solved because submarine technology has been around since World War II. But during World War II, well, actually the first submarines were World War I, actually. So you know that the submarines have been around for well over 100 years. But until much more recently, submarines had to surface or get close enough to the surface to have an antenna that can reach the surface in order to communicate back. You know, now they've done some work with underwater sonic communications out there, which is not as efficient, but out there. So, but there is the problem that there. And the other problem when you look at robotics underwater, and this is a huge problem, is GPS doesn't work underwater. GPS relies on a line of sight signal to a number of satellites. And for a GPS signal to work, you have to be in communication with at least 3 satellites to determine your location, right there. So it's not one of those things that you pick up one satellite and you're good. You need to triangulate your position, right there, with GPS. So underwater doesn't work with GPS, right there. That is another problem, right there. So, and that there. So the unmanned aerial vehicles, you've heard a great deal about those. That's kind of an ugly looking drone. That's an early drone right there. Unfortunately, both these, you know, and I'm going to kind of get off on a tangent here a little bit and talk about military spending, and in particular my home country, which I don't live in anymore, nor do I plan to return to live. And I avoid paying any U.S. taxes like the plague. Unfortunately, I can't get it away from it since I've got all my retirement savings there. But and I've worked in the military industrial complex. So, but when we look at modern technology, and you're the generation that has never lived without modern technology, you know. Your generation was born by the time you could start doing anything, you know, you started primary or secondary school, your cell phones were pretty much dominant already. Tablets were pretty much mainstream. Laptop computers were everywhere. So your generation doesn't remember life before technology. I get to be the old man and the historian here that they're. And I remember when my neighbor got his first color TV. There, I mean, when I grew up with black and white TVs predominantly, you know, I remember sitting on the front porch of my house up in St. Paul, Minnesota, in 1969, and watching Neil Armstrong walk on the moon on a 14-inch black and white TV on the front porch with my mother, and you know, that there. I don't know where my dad was. I think he was watching it in the living room on the bigger TV. But regardless, I watched that on a black and white TV. We couldn't afford a color television set yet. Most homes had one telephone that was hardwired to the phone company. That there. Yeah, and it had a rotary dial. You know, bzz, bzz, bzz. You know, people still talk about dialing a phone. None of you have ever dialed a phone. You push the push buttons. You have actually used one of the antiques, huh? Maybe some of the old pay phones here might have still had them, right? Or you may have still had some at home. But I was thinking nobody in this room probably ever saw a dial phone, but I'm wrong, and that there were still a few of them floating around out there. But a lot of what we've got in terms of technology today is a direct result of two major events, and this is where, growing up in the U.S., I can kind of talk about it, is the space rush, the space race between the U.S. and the Soviet Union meant a lot of money was put into space development. And this money was put into space development. A lot of it had to do with ego and pride, and a lot of it had to do with military, who could blow each other up first, right there. Rockets were designed initially not to send people to the moon, but to carry nuclear weapons to bomb people. You hate to think about that, but that was the original intention for robots, and for spacecraft out there, and rockets out there. And still, probably most of the rockets in the world today have that purpose. North Korea is trying to develop rocket technology, not because they want to put a satellite up there so that they can watch American TV shows in North Korea, but so that they can threaten the world with dropping nuclear weapons, at their doorstep if they at their. However, a spin-off of all that money spent got us much more efficient jet engines, got us much better electronics, has got us faster and more robust computer systems, much smaller. Satellite communications is a lot, which again was developed predominantly for military purposes, right there. Got us things such as cell phones. It brought us, the internet was actually a Department of Defense initiative. It was a DARPA project that there. So all this military hardware, which I love to hate the military. I love to hate the military, and I can hate the military. I wore a uniform for 9 years, so I spent 4 years in the Air Force and another 5 years in the Army Reserve. So I wore both an Air Force and an Army uniform out there. So I'm allowed to hate the military out there, having spent enough time in the military and then working for companies that support the military. So I'm very familiar with the military out there, and I don't hate the military as much as I hate the policies of the people above that drive the military out there. I mean, that's who I hate. The guy that's wearing the uniform, he's just like I was when I was 20 years old. I mean, he needed a job and he needed skills and he needed, that there. But a lot of what we're looking at today, as far as what your generation is reaping, and I'm going to refer to your generation, is the fact that because of all this money that was spent by not just the U.S., the U.K., France, Germany, Russia, South Korea, Japan, all this money that was spent on developing military hardware. Now, Japan and Korea don't develop a lot of military hardware, but they develop a lot of things that they sell to the U.S. That there. So, I mean, actually, Texas Instruments here sells some of their ICs to the U.S. military as well. So, I mean, there's a lot of companies that are supported internationally with military electronics sales. But a lot of this work was done to support military hardware. Unfortunately, in military hardware, somebody always tries to use it. That's the bad thing about it. If they built it and left it on the shelf and tested it and never used it, I would be fine with it. But unfortunately, someone's got to use it. But both these particular examples, along with this example here, were predominantly developed with military applications, right there. Now, the industrial robot, which we're most interested in this class, the first aerial vehicle or drone was actually developed by Israel. Yeah, in order to do reconnaissance in occupied territories, like that there. So, and that Israel didn't build it for hobbyists to play with in their backyard. They had a military application for it right there. So Fortunately, Malaysia doesn't spend a lot of money on military that there. Yeah, that's kind of a debating that there. I've got a cousin, my wife, technically he's my wife's cousin, who's a retired lieutenant Air Force colonel. And I did some work with him we've had long discussions, and he feels that that Malaysia should do some research in the military like Trump, that there. And again, not for the sake of military, but because it is such high bleeding edge, to bleed off back to that there. And if you look at the development cost from scratch to develop the iPhone, and the iPhone is undoubtedly the first and oldest smartphone out there, right? You know, some of you might use iPhones. My wife uses an iPhone. I personally am in the Android world, right there. But if you look at the technology research to develop the tiny little system on a chip microprocessor with gate array technology around it, you know, custom IC. You look at the digital signal processing involved in the iPhone. You look at the storage capacity to store. You can get them with 128 gig of memory to store. Although on my phone, I've got an Android, I got a 200 gigs memory chip in it. Hey, you know, there's a lot of music back in the 70s that there I still like. You know, I got to fit it all on my phone. That's there. But regardless, if you look at the research for all that, and if you expected private corporations to spend that kind of money out of their budget to do that kind of research, it would have never happened. So all that research had to have been funded by governments. And the way it was funded by government was under pretense of both the space race and military. So all four of that there. Now here we're getting more into the what can robots do. Number one thing that they are very good at is they can go into places that people can't. So that's why a lot of the early robotic arms, a lot of the early robotic tools were designed for the space program. Right there. You know, it's a lot easier to have a robotic arm go out and repair a broken heat shield on something like the shuttle than it is for a man to suit up in a suit and try to go out there with the great big gloves and try to do it himself. I mean, here they're looking at cleaning the main circulating pump housing in a nuclear plant. I don't know about you, but I'm not hanging out inside the reactor area of a nuclear power plant. Right there, that's just not my area. A lot of medical decontamination falls under that there. There's a lot of organic germs, Ebola, HIV. These things kill people very quickly, right there. And if you can not handle them, that they're with your own hands, even with rubber gloves, you're better off. That there. So robots can do jobs that are very dangerous, right there. Get into places that we can't. This is probably the number one application of robotics in the industrial world. Repetitive jobs that are boring, stressful, or labor intensive. I remember being 18 years old and getting a job at a factory that made loudspeakers. And I wanted to work at this factory because I could buy pile driver speakers cheap from the factory store right there. I mean, so, you know, it didn't pay much yet there, but, you know, I was 18 years old, maybe even 17 at the time I got the job. And believe it or not, my job was to sit on a lab stool or a bar stool. We called them bar stools back then because you normally found them in pubs, but, you know, something about this tall. We sat there, and then the assembly line would come by and these speakers would come by. And my job was to reach over with my arm, and I can't do it very well because my arm doesn't work, but reach over, pick up a magnetic speaker core, which was not magnetized yet. It was just a hunk of iron. It weighed about half a pound or 3/4 pound. Pick it up and put it on the speaker cone as it went by. And I did that roughly, you know, 60, 70 times a minute type thing. You know, maybe not quite that fast, but that was my entire job. Was just to pick up this, put it there. pick it up, put it there. I had another job a few years later out there, and a lot of people, I went to college because I worked so many factory jobs that I hated that I figured out that I needed to go to college to do something other than work in factories or agriculture. I wanted to do something I use my mind and not my back out there. But I had another job working for a company called Lock, Steel, and Chain, which you probably, and they made chains for tractors and things like that, these gear chains right there. And my job was to sit there and push a button to make a chain link. And I would just keep pushing this button. That there. And I had to watch to make sure that the previous link ejected properly out and attached before I pushed it the next time. Otherwise, they would just hold the button, bop, 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 bop. But you needed to sit there. Again, one of the most boring jobs on the planet. Out there, I mean. By the way, the loudspeaker job, I lasted all of 4 hours on that job before I quit it. That there. The second job that I talked about, I lasted all of about 2 weeks before I quit that job. That there. I mean, I couldn't handle these jobs. I mean, they were very repetitive. They were very boring. Repetitive and boring right there. They weren't stressful or labor intensive. I mean, sitting there holding my thumb on a pushing a button, 200 times a minute wasn't very intensive. Picking up these magnets and moving them. I mean, I'd get a sore shoulder. I can't talk after probably a year or two of doing that. But I mean, it wasn't stressful or labor intensive. I mean, I didn't have people screaming at me or anything like that. I didn't have to worry about that there. But they were just boring as crap. That there. And those aren't the kind of jobs anybody wants to do, right? So that there. Other jobs, such as the welding. Doing welding is a skill. It's a very, very intensive skill to train a welder. I tried welding once. I wasn't good at it. That there. One of the things you learn as you get older is that things that you weren't good at when you were younger, and you realize that you weren't good at it, was probably good that you realized you weren't good and you didn't force it. And they tried teaching me to weld one time, and no, I burned up the welding rod out there. I just could not move that beam across on the arc welder. But robots could do that, do welding very, very well. And they could make perfect welds right there. So better than people. So there are things robots are better than out there. So menial tasks that people don't want to do. I haven't got the Scrubble-mate robot yet. That's a little bit of overkill here, this example. Actually, these are different slides that I went through last time, so they're more entertaining, actually. The Scrubble-Mat robot that there. But I did buy the iRobot that goes around the house and vacuums the house. They've got the version that actually mops the floor afterwards. That there. Yeah. The only problem with the one that mops it is that it does like maybe a quarter room, then you have to empty the water and put fresh water in that there. So doesn't save you a lot of time. It's actually easier to just mop that there. But the vacuuming is pretty sweet. I mean, I just put up the two little barriers. I mean, they're little posts that tell not to go past that there, and just turn the thing on, and 30 minutes later I move it to another room and it vacuums the next room. I mean, it does do that there. So there are a lot of household appliances that aren't robots, but they got kind of the same mindset. I am completely shocked that they're starting to come out here as dishwashers. Does anybody? Some of you have seen dishwashers, right? The electric dishwashers. Pretty much every home has an electric dishwasher in the U.S. My wife moved to the U.S. about 10 years ago. It wasn't quite 10 years ago. She lived in the U.S. for about 10 years ago, and it took her probably 2 or 3 years before she was comfortable using the dishwasher. We bought a dishwasher here. We put it in, and she still doesn't want to use it. She says it's easier just to wash dishes. I am the complete slug in terms of wanting to do manual work. I I eat a meal, I do a quick rinse and get the hard stuff off, and it goes into the dishwasher. After 3 or 4 days, I run the dishwasher, empty the dishes out, put them away. I don't expect me to spend 30 minutes behind the sink washing dishes. So again, but that's again, even though the dishwasher is not a robot under the sense of robot, it's a piece of automated machinery that uses electronics, mechanics to do a job that a person used to do. So in my opinion, it's very similar to a robot in the fact, and that's what I define as robot, is something that replaces a person to do that there. A little history lesson. Does anybody have a clue what the first job was that was replaced by a robot or a machine? Anybody want to take a guess? No guess. A piano player. The old pianos that had the little spools that you wound up on a spring, you went through and played the piano in the pub. They called it the player piano. That was the first human job that was replaced by automation. Was the piano player in the old saloons in the West. And they came up with the player piano concept because it was so hard to find people who could play pianos that were willing to work around flying bullets. You know, in the 1840s and 1830s in the old American West, people tend to get in gunshots after drinking a little too much rock gut whiskey and playing cards and cheating. That piano players were getting shot once in a while, so nobody wanted to play a piano in a saloon. So they replaced it with the player piano right there. So, you know, that's just kind of a little history. You know, it won't be on the final exam. That would be a very tough question to stick on a final exam. But, you know, but if you think about that, that tells you that for 150, 170 years, there have been people replaced by automation in many, many occupations over the years. So the fact that this trend is going to continue is something we need to keep in mind. All right. The word robot was actually a Czech word. I can't remember where the exact root for it, but it's robota in Czech. That doesn't sound right, but I think the author probably couldn't find the original root. That means worker or servant. So the word robot means a worker or a servant right there. So definition of robot made by any of our members up there. Now I look at this second definition as the key thing right there. The first one I don't care about, any machine made by the Robot Institute of America. That's a self-serving definition right there. But the second one actually has some meaning. A robot is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools, or specialized devices through a variable program motion for the performance of a variety of tasks. If you look at that definition, the dishwasher kind of falls under that, right? That there. The automated washing machine falls under that. Now, some of you might have parents that are very old school that wash clothes by hand, or may have seen people wash clothes by hand. I actually had a washing machine when I first moved to Malaysia 20 years ago in the house that I was renting. I hired an Indonesian woman to come over to my house and pick up my dirty clothes and wash them for me and clean my house. I don't remember what I paid her at the time. It wasn't very much. She lived next door it was a semi-D, and she lived next door and cleaned their house. She was their maid, so she came over and took care of my house for so much per month. And she never used my washing machine. She always went out and washed my clothes in buckets by hand out front. She did not want to use the washing machine. She was very old school. She didn't have a washing machine where she lived in Indonesia, evidently, and wasn't used to using washing machines there. I still find my wife, and I scold her every time because, you know, especially in the last couple months because she's got a bad shoulder, in the bathroom sitting on a stool washing delicates by hand. And I said, what's wrong with you, you know, that there? I'm the one who had the stroke and's got the brain damage here, that there. Why are you doing this? We have a washing machine out, in the back part of the house, that there's, you know, it's wet kitchen we added on. That's got a delicate cycle. It's designed to do exactly what you're doing, to wash clothes that are very delicate. That's why they put a delicate cycle on a washing machine, right? There's no need for you to sit there and wash, my Baju Malayu type shirts. You know the type I'm talking about, the silk shirts that are very expensive here. There's no need to wash those by hand. You just put them in the delicate cycle, and in 15, 20 minutes you take them out and you dry them. That's what the delicate cycle is for. And I'm sure some of you still have mothers that do exactly what I'm talking about, right? Yeah, that there. So, and of course, she's your mother. You're not going to ask her what the frick is wrong with her. We don't have any ladies in the class today, but they made it. But what's wrong with you? Why are you not using this machine that you just throw the stuff in there, put it in a little detergent that there, and you can use the woolite or the, delicate, material detergent, and just hit the delicate mode, and it will gently rock it back and forth, and it will spin it slowly in order to not stretch the material. But the machine is designed to do that there. So, does it make your life easy? You betcha. That's a saying up in Minnesota. Betcha, you betcha. That there. If you ever seen the movies Fargo or TV show Fargo, you might have heard that slang before. But you know that the whole idea of robotics and automation is so that we don't have to work as hard as your great-grandfathers did or my fathers did. So you don't have to get a job in a factory moving magnetic coils 8 hours a day, right there. So that's the whole idea of robotics. And you work 3 weeks in the class. The three rules we talked about in great detail. I'm not going to review them again. The first industrial robot, the Unimate, I forgot all about this there, Universal Automation, right there. And it was actually developed by a company in Indiana, right there, RCA, that made television sets there. And they were used to make the picture tubes for the old CRT, cathode ray tubes, right there. These things were as the TVs got larger, they got heavier, they're made out of glass, they're very fragile. So this was made to move those things around on the assembly line, right there. So that was the first industrial. Now, other automation tools were developed by the automotive industry, and we'll get into that. Puma is the one that most people consider, most people forget about the Unimate. I forgot about it until I saw this slide because there's a very special purpose robot. It only did one thing, right there. Puma was the first one that most people think about. And Puma looks a lot like the robot we've got downstairs. We'll go down there and look at it and just, unfortunately it doesn't work, so, so we can't play with it. I wish we could play with it, but it's a very expensive piece of equipment, and somebody managed to fry it a few years back, and no one's found the money to fix it, nor do I think anybody's got any heart to fix it because they know that somebody will probably break it again. But this particular robot, it's got several degrees of freedom. We talked a little bit about what degrees of freedom mean, but it can rotate this way. This thing can go up and down. This arm can go up and down. This actuator here does not move in and out though. So it's got a fairly limited degree up there. But It's designed, again, you'll notice this company comes, their name comes up a lot when we talk about robotics, right there. I mentioned the Department of Defense, you know, and their military and the space and NASA, and their influence on robotics and some of the special purpose robots that they're. NASA and the Department of Defense had a huge impact on, you know, unmanned spacecraft, unmanned flight with the drones, underwater, that they're some of the munitions, you know, some of the robots that look for weapons on the ground, do search and rescue. The leader of the industrial robot revolution was probably General Motors, right there. Now, the assembly line in modern industry, as we know it today in terms of manufacturing, was developed by Henry Ford back in the early 1900s. You know, he developed the concept of the assembly line and putting the car together one piece at a time. One person had one job. We didn't have robots then. You know, people. You know, there was a person that all they did was they put the tire on. The next person bolted it on. The next person, you know, put the steering wheel in or whatever. But the car was assembled one piece at a time, and he quadrupled the production, because before a team of 4 or 5 people would put together one car, right there. You know, so another company called Pontiac, yeah, which was later bought by General Motors. They perfected the process and made it a little bit better. That there, so, but again, the automobile industry probably did the most in terms of robotics or industrial automation. Now, obviously, the Industrial Revolution was well on our way back in England in making silk and making other cloth, that they're way back in the 1800s. But the automobile manufacturing, and then later split off to other types of manufacturing, really drove a lot of the early automation right there. So the 80s was probably the golden years for robotics in terms of industrial. Industrial robots have gotten better since the 1980s. They haven't changed drastically. They've gotten smarter, and they've been used in other areas. In terms of factory robots, the one that we're going to be using in this lab to, we'll start looking at it on Thursday. It uses servo motors. They haven't changed a huge amount in the last 30 years, 40 years. They really haven't. What has changed is they've gotten smaller, they've gotten a little bit more efficient, they've gotten smarter. I'll show a video later on about a robotic cow milking machine that uses cameras and will bring out the little cups and put them on the udder of the cow and measure the milk output and take them off when they're done. And it actually shows it washing the udder before it, but the robot actually milks the cow, and you no longer have the little milking girl on her there on the bar stool doing the milking, pull into the bucket. I'm sure most of you probably haven't seen cow milking in person, but I grew up in a dairy state. I saw a lot of cow milking there. So, but robots haven't changed a great deal. A lot of the intelligence of the robots have gotten a lot smarter. But from an industrial setting, they haven't changed a great deal. Outside industry, like the video I showed with the humanoid robots, and there are several other videos in the series, but that was the one that was most spectacular. That's why I picked that one for you to watch. Robots are definitely getting smarter, and they can do more in terms of decision making than that. But in a factory setting, that isn't as important as it is in humanoid type robots, military that they're self-driving vehicles. Again, is a lot of decision making. Right there. I was reading an article this morning while I was at the hospital, waiting for my wife to come back from a test, about the number one job that's going to be probably replaced in the next 10 years with robots it's going to be in the transportation sector. Truck drivers, bus drivers, airline pilots. You know, those are going to be replaced in the next 10 to 15 years, right there. So those of you that plan on graduating and making your living as a taxi driver, I suggest you rethink your career plans, right there. So, right there. So, present today, again, right there, this is 95, of course, that's 20 years ago, 22 years ago to present. Emerging applications in small robotics and mobile robots drive a second growth of startup companies. So you had the glory days in the 80s with the industrial robots, right there. So that research really isn't very prevalent today. I mean, industrial robots is a very mature industry. And that's why I'm not going to spend a lot of time talking about industrial robots and how to program them, because industrial robots come with their own programming modules, their own programming manuals, and I'm not going to spend a great deal of time going through that there. I'm going to show you examples of how they're used and why you would use them in what applications, but I'm not going to get into the hardcore design because that's mature technology dominated by the Germans and the Japanese. I mean, there's a few American companies in there, but German and Japanese companies kind of dominate that industry. Mitsubishi's a big one, right there. Siemens is another one, but they're pretty much dominated by that side of the world. Now, most of the work that is being done is in small robotics and mobile robots, right there. You know, the drone has taken off as a major robotic type thing. Now, the word drone is not completely automated. You still have the remote thing and the camera, but it is using robotic type technology. And you could put a microcontroller and tell a drone to fly to a particular place, take a bunch of photographs and come back, which is what Israel did with the first drone. Right there. You know, that was the idea. That you know, the U.S. has been doing that with the Soviet Union until, well, they were doing it with manned spacecraft until Gary Powers got shut down in the 1950s. They used to fly airplanes over the Soviet Union and take a bunch of pictures. Now they just put satellites up there to take the pictures. So there's no need for spy planes anymore to take pictures. Satellites do a pretty good job. Just look at Google Maps and you can tell how good these satellite images are. You know, I could tell what car is in front of my house when they took the picture. Oh, and contrary to popular belief, Google Maps, those are not live images. Those are that there. So, again, here this particular author points out in 2003, which is again 15 years ago, 14 years ago, the Mars space rover that there was launched. Again, that was a six-wheeled vehicle, solar powered, obviously, right there. Communication links back to the U.S., or well, actually not to the U.S., but the satellites, you know, rotating over Mars, that there. So, but you had, again, that there. But if you look at the technology required to build this, and you look at what Tesla and Uber and Apple are doing with self-driving cars, you see the linear progression of how the technology has gone from space exploration into commercial applications right there. And unfortunately, Malaysia is not a place where you find a lot of university research that's cutting edge. They do, they I won't say anything negative. The funds just aren't there. Yeah, there isn't a NASA to fund research projects at the University of Malaya. It's just not there. So, not there. So, okay, where are we on time? Yeah, I'm going to go ahead and continue to about 1:30. Okay, this will be on the final exam, right there. And I went through this before. This here is kind of a series of what's required for robotic systems, right there. So we have dynamic system modeling and analysis. So everyone here is taking a course in feedback control systems, right? You know what I mean by a feedback control system, or you should before you graduate. But you should know what's system modeling. Analysis. That's a feedback control, of course, is part of the system model. System modeling you've been doing since day one. Sensors and signal conditioning, we'll talk a little bit more about that in this course. The various types of sensors right there. So I'm going to talk a little bit about sensors and signal conditioning right there. Actuators and power electronics. I'm not going to spend a great deal on power electronics because Dr. Ibrahim teaches a course in power electronics, right? Or Dr. Fadi, one of the two. But power electronics is taught by somebody in the department, right there. Everyone's had at least one course in microprocessors or microcontrollers and interfacing, right there. So that's all part of the robotic, what goes into robotics, right there. And some of you might have learned something when you took C programming, right there. Some of you might not have, right there. But computer programming. These are all the major tools required for building robotics. Now, also in this, I'm going to put in here, I'm going to circle mechanical engineering as part of that as well. Mathematics, of course, is part in everything, right there. Physics is part of, you know, especially mechanical engineering part of it. Biology wasn't so much until recently. Now biology is starting to come into play here. So you missed the part where I said this page will probably find its way on the final exam. So that's there. And I'll put these slides up on the course website. That's there. So that's there. I mean I get it done today. If I don't get it done before Thursday, remind me Thursday, and during class on Thursday I'll put them up. That's there. So the disciplines that feed into robotics, again, the major ones is mechanical, electrical engineering, computer engineering, computer science are the big ones. You don't find very many physicists that become robotics specialists. You know, physicists are kind of a general purpose degree. You don't know enough about engineering or applications. It's more of a teaching / research area right there. So physics, and I don't think physics is a very popular major in English, is it? It somewhat is in the US, but most physics majors I know end up transferring to engineering at some point, or they go on to graduate school and get an engineering degree. It's hard to get a job with physics. Same thing with mathematics. I mean, 80% of mathematics majors end up teaching. You know, there's not a demand for, you know, Unit 10, or not Unit 10, Tanaga National to hire too many mathematicians. You know, there is now, I would say that that's different if you're talking about statistical analysis and things like insurance companies, right there. Insurance companies do a lot of research on probability of how long people are going to live, what type of people are more likely to have car accidents in order to get there. So statistics plays a lot in the insurance industry, right there. But mathematics, of course, is just the background of most engineering. Biology, again, is coming to play with the humanoid type, and they're looking at biology, but it's not actually a core field that you think of that there. Computer engineering is a big part because you know, the programming, you know, and it's just not, you know, I look at computer engineering as a huge area of growth because that there, especially software design, is if you look at something I read from that Boeing put out a couple years ago, and I was working for Mike, and we were doing a lot of research on aircraft development and aircraft costs up there. And one of the things that Boeing stated pretty bluntly is that 50% of the cost of a new aircraft plane, like a Boeing 787, is the avionics or the electronics on board. That's 50% of the cost of an airplane. Now, if you look at these big General Electric or Rolls-Royce engines and all these seats and all this fuselage, that's only half the cost. the electronics that control all that is just as expensive as the plane itself. And what's even more interesting in what Boeing was saying in this particular press release, or well, it was a white paper, it was a press release, that there is that 25% of the development cost of a new aircraft, or 50% of the cost of the electronics, is in software design. So if you look at $10 billion it costs to create a new airplane, and that's probably a small number, you know, that they're to design, build, and test, and perfect a Boeing 787 from inception to putting the first production unit out, and Malaysian Airlines buying the first one, which I know they won't buy the first one, but you know, putting the first one out there, and Etihad airline or whatever buying the very first one. $10 billion, 25 billion of, or no, I said 10 billion. 2.5 billion of that is just in writing the software. Another 2.5 billion is just in designing the hardware that the software runs on. So 5 billion of the 10 billion cost is in the electronics area and the computer engineering area. That there. So now that's with cars, or I mean with automobiles, or with aircraft. Now we've got UK says 2035, India says 2035, Denmark says 2030. All electric cars, no more that they're, the same rules going to apply to cars. I'm going to wrap up. It's a call for prayers anyway. Okay. I will see how many slides have I got? Oh, I only made it. I said I was going to finish these 50 slides. I lied to you. Well, we'll pick up. But I'm still going to bring the robot in. It took longer. These are different slides than I had last time, but better slides.